Welcome to today's lesson. In this tutorial, we will solve radical equations and check for extraneous solutions and solve rational exponent equations. So we're in our next section, 6.6, and we're solving radical equations. Before we begin, I'd like to look at an important property for today. Let's say we have the square root of x, and we take that and we square it. Taking the square root and then squaring basically undo each other. Squaring a square root, they are inverse operations. So this would be equal to x. If we take the fifth root of something and raise that to the fifth power, because the index and the exponent are the same, they will cancel out because they are inverse operations. And then a would be all that's left, just the radicand pops on out. So if we have the cube root, to undo the cube root, all we need to do is cube. So if we have a cube root and we want to undo it, we cube, and then we would just have whatever's underneath that radical symbol, which in this case is m plus 5. Nothing happens to the radicand as long as we undo the index with that correct exponent. So that's an important part today. What we're going to be doing is we're going to be isolating our radical because we're solving radical equations. We're going to get the radical to be all by itself, and then we will unlock our variable by raising both sides of our equation to whatever the index happens to be that we need to cancel away. So here are our steps. We're going to isolate the radical. What that means is get it all by itself. Any other numbers that are on the outside of the radical have to go away. Isolate the radical. I like to put it on the left side of our equation. I also like to throw in step 2. If we can, I'd like to, once we've isolated, just mentally check to see if our equation even makes sense. We'll talk about that with example 2. And then number 3, if we have it isolated and it does make sense to continue, we're either going to square both sides or cube both sides or raise both sides to the 4th power or the 5th power or whatever power we need to unlock the index that we see. We're going to raise both sides of our equation, and this will unlock our variable. You can see the radical goes away and then our variable is just sitting there. And then finally, once we have that, we'll just solve our equation. We should have an equation that we know how to solve. We'll solve the equation, but we must check for extraneous solutions. We've looked at extraneous solutions before. An extraneous solution is a number, or numbers, I guess, that does not check. It does not work in the original equation. What we need to do with our radical equations, once we think we have the answer, we need to check our numbers and make sure that they work in the original equation that's been given. Because if it does not work, if it does not check, it is an extraneous solution. Okay, and that's your vocab word. Great. Let's look at example number 1. I see that we're dealing with a square root, but this square root is not yet isolated. Remember, it has to be all by itself. We have this subtraction of 5 here. So let's undo that. Let's get rid of the 5. Anything that's on the outside of my radical, I can just treat with regular operations. So we'll just add 5. And I'll have the square root of x plus 2 is equal to 5. So now this radical, this whole square root, is all by itself. It's isolated. I like to mentally check to see if this can happen. What I mean is, can we have a square root that is equal to 5? Well, yeah, of course. The square root of 25 equals 5, so this is able to happen. So what I'm going to do to undo a square root, I'm going to square. I'm going to put parentheses around the entire left side and square. I'm going to put parentheses around the entire right side and square. We're going to square both sides. Squaring the square root unlocks this x plus 2, and we just get x plus 2. Squaring a 5, of course, we get 25. That's a pretty simple equation to go and solve. In fact, all we have to do is subtract 2 from both sides, and we'll have our answer. X is equal to 23. Now, before I box this in or circle it, I do want to mentally check. I want to check to make sure that this is correct. So I'm going to plug the 23 back into the original equation. 23 plus 2, well, that's 25. The square root of 25 is 5, and 5 minus 5 equals 0. So I'm going to put a little check mark that I have checked this. It does work. So I have my answer. Excellent. Let's look at number 2. We're also dealing with the square root, so ultimately we'll probably be squaring to get rid of the square root. But I cannot square yet because it is not isolated. I have this 9 that's sitting over here. It's a positive 9, so I'm going to subtract 9, and I'll just do that from both sides. Whoosh. This positive sign doesn't need to be there anymore. We just know that we have a positive square root. Great. Square root of x minus 1, and this is equal to 4 minus 9, which is negative 5. Because I have step 2, where we're mentally checking to see if our equation makes sense, I want to see, does it make sense to have a square root that's equal to negative 5? And now I can say no. That doesn't make any sense. Square roots cannot be equal to negative. So that means that there are no solutions here. I'll put the null set. That saves us some work. If you can see that this does not make any sense because we can't have square roots equal to negative, then you can just jump to the, well, there's no answer. If you don't see that, and you come off to the side and you square both sides, squaring this side, we would get x minus 1. Squaring this side, we would get positive 25. Going and solving this equation, it appears that our answer would be x equals 26. But this does not work. If I plug a 26 into this equation, to the original, right, the 26 minus 1 is 25. The square root of 25 is 5. 9 plus 5 does not equal 4. This does not make sense. This would be an extraneous answer. And it would be kind of a waste of time because we didn't need to do this. If we see that a square root equals negative, we know that we're finished. It cannot happen. Null set. Let's look at example 3. Example 3, okay, now we're dealing with a cube root. The good news is the cube root is isolated. It's all by itself. Everything that we see underneath this cube root is the radicand. I can't get into this 4a plus 1 until the cube root symbol goes away. So that's why I'm going to cube both sides. Now some people might be saying, wait a minute, it's equal to a negative. But that's okay. Cube roots can be equal to negatives. It's square roots and fourth roots and sixth roots and eighth roots. Any even roots cannot be equal to negative. Odd roots can. The cube root of negative 27 equals negative 3. So this is okay because it's an odd index. I'm going to take both sides and I'm going to cube. Put parentheses and cube. Cubing a cube root undoes each other and we get our 4a plus 1. Cubing negative 3, which is negative 3 times negative 3 times negative 3, is negative 27. And now we have this pretty simple equation. We just go and solve this. Let's subtract 1. 4a is equal to negative 28. And let's divide by 4. And it looks like our answer is going to be a equals negative 7. I would like to check this. So I'm just going to mentally do that. 4 times negative 7 is negative 28. Negative 28 plus 1 is negative 27. And the cube root of negative 27 is indeed negative 3. Put a check mark. I have checked it. Let's look at example 4. We have a square root. It is not isolated yet. This square root symbol needs to be all by itself. So this 12 needs to go away, and this minus sign needs to go away. Let's get rid of the 12 first. Let's subtract it away. Whoosh. I have a negative, and then the square root of 3m minus 7 is equal to negative 7. Now don't stop too early. This is not a square root equal to a negative. This is the negative square root equal to a negative. This negative sign, since it's still on the outside, needs to go away. I can divide by negative 1 or I could multiply by negative 1. Either one of those will get rid of the negative sign, and I'll have the square root of 3m minus 7 is equal to positive 7. A square root can be equal to positive 7, so we can continue. We will take both sides and square, both sides and square. Squaring a square root undoes each other, and we get 3m minus 7. Don't forget to square both sides. 7 squared is 49. And now we have some simple math to do this. We add 7. We show our work. We have 3m is equal to 56. It doesn't feel too good because 56 is not divisible by 3, but that's okay. Sometimes we get fraction answers. Looks like m is going to be, I'll just leave it as 56 thirds. Now I would like to check this. Now I know that this is a fraction and we could plug this in. It's not too bad, but maybe I want to check this using my calculator. So let me show you how we can do that. If I pull up the calculator, I'm going to show you how to store this into the calculator. If I push 56 thirds, 56 divided by 3, and whatever, I press enter, it's going to be some decimal. If I want to check this number, let's use the store button. The store button is right here above the on button. So I'm going to push store, and it's going to store this previous answer, this 56 thirds. I'll just store it in as x. I know that we used an m in this problem, but I'll just store it in for this variable x. You really can store it in for any one of the letters, a, b, c, d, e. I'm just going to store it in for x and press enter. So now it's stored in for x. Now I just need to type this side of the equation and see if it's equal to 5. So I'll have the 12, and then the minus sign, and then the square root. So I'll pull up the second square root, and there it is. And let me put, instead of 3m minus 7, I'm going to do 3x minus 7. And there's the thing. If this is correct, if 56 thirds is the answer, then this should be equal to 5. Let's push enter. Hey, it works. So you can use your calculator to check, and I'll put a little check mark and say that works. What we did was we used the store button, the stow, it says on your calculator. And that's very handy if we need to check, especially some sort of fraction. Okay. Let's look at example 5. Oh, what happened? Okay, let's look at example 5. So now we've got we've got two different square roots. Okay, well, if we have square roots on both sides, that's okay. Squaring will still undo our square roots. We do have this 3 on the outside, though. And I know that that means that this radical is not isolated. But if we divide the 3 away, then it's just going to attach itself to this radical. And there's no way to isolate both of these radicals. It's okay. It's as isolated as we can get. So I'm going to put parentheses around this side and square, and parentheses around this side and square. What I need to remember, though, is since the 3 is on the outside, it needs to be squared to get 9. The y minus 1 is on the inside, so yeah, the square root will undo with the square, leaving the y minus 1, but this time I'm going to put it in parentheses because there is a 9 attached outside. So anything on the outside still needs to, deal with the exponent, and 3 squared is 9. All of this stuff is on the inside, so when I cancel it out, I just get it down here, 8y plus 1. So there's my new equation. Let's go ahead and distribute that 9. Some people might do that in their head as they go. 9y minus 9, that's fine, equals 8y plus 1. Okay, and now we'll solve. I'm going to choose this side to bring my variable, so I'll bring my 8y, subtract it over to here. At the same time, I'm going to add 9. I can do 2 steps in one. So 9y take away 8y is just going to be 1y, and 1 plus 9 is 10. Okay. So it looks like y is 10. This is a type of equation that we definitely need to check for extraneous solutions because I don't know if this is going to work or not. There was no way for me to tell in the beginning, like step 2, does this mentally work? Because a square root can equal a square root, sure. We just need to know if y can be equal to 10. So let's mentally check. Does 3 times the square root of 10 minus 1 equal, I'll put a little question mark, the square root of 8 times 10 plus 1? So that's ultimately what we're trying to figure out. So this is 3 times the square root of 9, and this is the square root of 81. Well, this is 3 times 3, and this is 9. Yeah, that works. 3 times 3 equals 9. It works. 10 is fine. So watch out. I showed you this one. To watch out for this. Anything on the outside and you square both sides, you're squaring that thing on the outside to get the 9. All right, and let's look at this next one. Now we've got a square root, and it's equal to a binomial x plus 3. Well, the square root is isolated. It's all by itself. And that means that I know that I can instantly go and square both sides. I'm going to take both sides and I'm going to square it. Notice that I put parentheses around the entire side. Squaring the square root, I just get the x plus 5. But squaring a binomial is the x plus 3 times itself again. This is going to be a FOIL problem. You cannot just square individual pieces. That does not work. So we have to do our FOIL. So let's see what we have here. We have the x plus 5. And here my first terms give me x squared. My outer terms give me 3x. My inner terms give me another 3x. And my last terms give me 9. We've FOILed plenty of times. Let's get our like terms together. We got x plus 5 still. This is x squared plus 6x plus 9. So now we have this equation, and I know that this equation is quadratic. It has a degree of 2. That means that there are going to be 2 solutions, and I need to find both of them. So since this is a quadratic equation, I will start by setting it equal to 0. I'll probably solve by factoring. We could use quadratic formula or completing the square or even graphing. But I'm going to solve by factoring, which means I want to set it equal to 0. And I like to bring everything to the quadratic term. So I'm going to subtract x from both sides. And I'll subtract the 5 as well. Basically, all of this stuff I'm going to bring over here so that it's all equal to 0. I've got x squared, this is 5x, and this is 4. And it's all equal to 0. Now it's in standard form, and I can solve by factoring. I'm going to factor this by splitting up the x squared into x times x. The 4 will be 1 times 4 and 2 times 2. Those are my possibilities. I've got my 0. Let me put my parentheses here. I know that the fronts have to both be x's. I know that it could be a 1 and a 4 or a 2 and a 2, but I know that I'm trying to get 5. So 1 and 4 will most likely be the winner. And I know that my signs must be the same because they have to multiply to give a positive 4. And since I also need a positive 5, they'll both be positive. You can double check to make sure that that's correct, but 1x and 4x, I'm confident make 5x. So now here are my two possible answers. X could equal to negative 1 because negative 1 plus 1 equals 0. And the other answer, x could be equal to negative 4 because negative 4 plus 4 equals 0. So these are my two answers. But I'm not going to be quick to box them in. I know that I need to check. Let's check the negative 1 in the original equation. So if I plug the negative 1 right up here, negative 1 plus 5 is 4. The square root of 4 is 2. Negative 1 plus 3 is 2. And I've got 2 equals 2, so that's good. Let's try the negative 4. Negative 4 plus 5 is 1. The square root of 1 is 1. Negative 4 plus 3 is negative 1. Wait a minute, that's no good. This gives me 1 equals negative 1, and that's no good. This must be an extraneous solution. Extraneous solution. So the only one that actually works is x equals negative 1. So this is a good problem to go back and review. When you have a binomial and you're going to square both sides, don't forget that you do need to FOIL. Most likely you'll deal with a quadratic that you'll solve by factoring, which will give you two possible answers. Sometimes both of them will work, sometimes only one works, sometimes neither will check, and they will both be extraneous. You definitely need to check your answers though. So that's a good one to review. Let's look at example 7. So example 7 and example 8 look a little bit different because in fact you don't actually see a radical symbol, but instead you see this fraction power, the 1/4 power and the 1/3 power. But what we learned in our rational exponent day is that these ultimately mean radicals. The denominator of a fraction exponent is the index. So x minus 12 to the 1/4 power could simply be written as the 4th root of x minus 12. And then we can easily see that this is a radical equation. So that's not too bad. If you see a rational exponent in an equation, you could just convert the expression that's being raised to your rational exponent into the radical that it actually is, and then we can solve. In this case, we still need to isolate the radical because we still have this 3. So let's subtract the 3, and we will have the fourth root of x minus 12 is equal to 6 minus 3 is just 3. So now that it's isolated, and I know that it can happen because an even root can be equal to 3, as long as it's not equal to negative, I'm going to take both sides. In this case, I need to get rid of the 4 index, so I'm going to raise to the 4th power, both to the 4th power. So the 4th root and the 4 cancel away, and I just get x minus 12. And 3 to the 4th power would be 3 times 3 times 3 times 3, which is 81. You can look on your powers table for that. One last step, let's add 12. And I've got x equals 93. And I could do a quick check. I know I should check in the original, but I'm going to check in the one that has the radical in it. 93 take away 12 is 81. The fourth root of 81 is 3, and 3 plus 3 is 6. It does check. And then our final one, again, I see a 1/3 power, so that's going to be talking about a cube root. But understand that the only thing that's being raised to the power is x. This 3 is not being raised to the 1/3 power. That's just being raised to its own power of a 3. Or excuse me, 3 to the first power. So that 3 is still just a 3. But x to the 1/3 is the cube root of x, and then equal to 24. So be careful. This 3 was really just, or is just a coefficient. And since it's a coefficient on the outside of my radical, I need to get rid of it, and I'll just divide it away. It's being multiplied to something, so undoing it by division. And I have the cube root of x is equal to 24 divided by 3, which is 8. Now I have this cube root, and it's already isolated, so I just need to get rid of the 3, and I'll do that by raising both sides to the 3rd power. So the cube and the cube root go away. I get x, which is nice. It'll already be solved. And 8 cubed is 8 times 8 times 8, which is 512. Oops, I was about to box it in. Oop, maybe I shouldn't do that until I check it. So let's check it. I'm gonna check it into the radical version of it. The cube root of 512, which is my apparent answer, is 8, and 3 times 8 is 24. So that does work. Great. So there's our lesson. I do want to leave you with one try problem, and I will check this when I go through our notes next class. Try 1. Create your own radical equation that has no solutions. And I'd like for you to explain in words why no solutions will work. So come up with your own radical equation that has no solutions and explain why you are correct. And I will check that in class. Thanks for watching. We'll practice when I see you. Bye-bye.